Hello. Can everyone hear me fine? Good, good, good. So hey, everybody. This virtual conference is quite a different experience. So let's try this out. Obviously, since I can't see your faces, I'm going to go ahead and assume that everybody in the conference attends this talk because that makes me feel better, as opposed to assuming that there's nobody else there. So this is my talk on Everything is an API. The background behind this talk is that after some time working in a large team, I spent some effort on trying to generify or kind of reduce the duplication of tasks and to make some utilities and these things. And especially with the advent of the architectural boom with MVI, with MVVM, all these different types, we're very, very keen as Android developers to try out new things. So this is my experience about trying to develop an API to use internally and having made mistakes and how to deal with those mistakes and how to recover from them, most importantly. So let's begin. Yeah, I'm Ash Davies, Google developer expert for Android, living in Berlin, working for Immoscout. So let's start off. What defines an API? What do you sort of imagine? What happens in your head when you think of an API? So obviously the literal definition of it would be a set of functions and procedures allowing creation of applications, and very, very textbook definition there. But it basically defines some sort of interface or some sort of wall between your application and another, and a way of abstracting and communicating between these two things. But when you think of an API, would you necessarily think how to retrieve repositories from GitHub, or maybe how to create a view model using the view model provider, sorry. Or would you, maybe think that repository you wrote last week for some weird module is an API as well? Well, if you're a bit confused as to which ones are an API and which ones are not, I think that the title of this talk is a bit of a giveaway. They all are APIs. Everything is an API that we use and interact with. And it's important to remember as well that when we're creating APIs or when we're writing this code, you have to think about how people are going to use it. And those people might just be your teammates or yourself in 2 weeks. So let's kind of think about the cost of this or the downsides of this. You have API decisions that apply to your API. You have an increased learning curve as a result of technical debt. It takes longer to peer review because your colleagues need to learn a bit more scope about what's going on. It's unpleasant to resolve. Nobody likes handling technical debt or legacy code. And it's an increased risk of bugs. Now, you obviously might be familiar already about the real impact of technical debt when it comes to APIs, because bugs and issues can manifest themselves later on during production, and then you have to deal with that often in a very panicked and frenzied phase. So you often don't end up with an actual good implementation at the end of it. And as a result, of course, the feature delivery is slowed because everyone has to then resolve its technical debt, or you have to then pay it back after some time. So this reminds me of this quote, which I really quite like, is debugging is like being a detective in a crime movie where you're also the murderer. You're probably all quite familiar with this. It's one of my favorites. But it got me thinking about this sort of double standard that we have with our API decisions. Like when we're using public APIs or public SDKs, we expect a level of documentation with it, or we expect it to be intuitive or easy to use. But we don't necessarily have the same level of expectation when we have internal code or code that we write for our colleagues. So where does this double standard come from, and what's it about? So it's important to remember that your code will always be consumed by other people. That will always be the case. And that other person might, again, be you in 2 weeks. Technical debt is often not repaid or paid back or resolved. And this is actually, this point is less selfless than it might appear. Have respect for your colleagues to make their lives easier. Now, this isn't just about being a nice, good person. This is actually quite a selfish thing as well, because the more time you take for your colleagues, you have to remember that they're going to do the same for you. So you're actually making your own life a little bit better as well, especially since the murderer might also be you. And finally, one of my own personal caveats is that test code should be considered production ready. So test code is basically just production code that didn't ship. Treat this with the same standard that you have with your live code and with your API-driven designs. Another quote that I quite like: always code as if the guy or the person who ends up maintaining your code will be a violent psychopath who knows where you live. If you are that violent psychopath, then I encourage you not to use my libraries. So let's assume that we want to be good citizens. We want to all be perfect in this world. We want to write good code, and that's admirable. So what does good code look like? Well, I can't really show you an example here because I have not written any. Good code is not necessarily a thing. There's no such thing as perfect code. Perfect is the enemy of good, you might have heard, or you might have heard the other phrase, perfect is the enemy of done. This is also called perfect solution fallacy, where you'll end up chasing this perfect solution for so long that you spent way too much time on actually getting a product out the door. So you end up with a much worse solution, or much worse situation, because you failed to actually meet the deadline. And this is a real problem from API maintainers, because if you have to then strive for perfection because you know you're going to have to maintain it afterwards, how can you be satisfied that the code you're producing, or the API you're producing, is going to be fit for purpose, or is going to be fine 1 year from now when you have to be still maintaining it? But it's important to remember that done is okay. Work on making it better. We have things to kind of help us with this. So this is a nice phrase that's a quote that I stumbled across, and the idea was that I'd be presenting in Paris, so a nice French quote would go down really well. I'm guessing it's still going to do that, but this is a French quote which I'm not going to disrespect the French language by attempting to say, but I will say it in English. It's a wise Italian once said, "The best was an enemy of good," which is quite insightful. So you want to code progressively through abstractions. You want to make sure there's enough of a buffer between your implementation and the API that you expose to your users or your consumers or your colleagues. So you keep your API surface as small as is possible, and you allow yourself room or scope for change. Try not to expose behavior in the implementation, and try and keep your kind of your cards close to your chest. So how does one go about this, hiding implementations through abstractions? We'll obviously prefer interfaces. And now a lot of exams, I'll actually see people creating interfaces for this one implementation of a class that might not always make sense. And you have to remember YAGNI also applies here, so you ain't going to need it. So you might be tempted, if the implementation is simple, just go with a straight class rather than an interface. Now, this is often true, and it depends if you are actually developing a library or if you are developing something internal. And if you want to go with a more compositional inheritance thing, then I would very much recommend going with interfaces, but then name your interfaces appropriately. Don't call your implementation my interface impl, because that gives no information about how it's implemented or what's going on there. And of course, make sure your interfaces are granular. So you'll generally want to prefer interface contracts, prefer composition over inheritance. This is computing 101. Interface segregation principle. If you're familiar with the solid design principles, this is one of the ones that actually applies here. And the interface segregation is making sure the interfaces are not doing too much, so that if you want, or if a consumer wants to implement your interface, they don't have to stub or mock all the different parts of the interface that make no sense for their use case. So it means that you end up with really granular, self-controlled interfaces, which are responsible for only one or few responsibilities, which is where it actually plays the responsive principle, which, if you will listen to me, is the only relevant principle from the entire solid design concept. So one of the tools that I use to sort of give me a clue here, or kind of give me a bit of a head start, is to have a really low tolerance for code smell. So anything that could possibly be conceived as code smell, I consider as such and use it. Every time an interface impl is written, a puppy dies. I like that comment. Yeah, so I try and have a really low tolerance to code smell, and I consider things that you would probably not consider as code smell as code smell. So for example, that might be conditional statements. If you consider every if-else statement as code smell, then you start to think, what am I doing here? Is it necessary? Can I abstract this or behave a different way or execute this in a different fashion? It also results in less indentation, which I'll go into in a second. But if you have excessive iteration or recursion, this is often a sign of code smell as well, because you generally can get away with one iteration most of the time. And if you're familiar with the coding challenges or any of the leak code problems, you'll obviously be familiar with this as well. Significant indentation, you'll notice this. It's a bit of a Hadouken meme where the guy from Mortal Kombat's throwing the flame into the code. It doesn't read very well, and I think there's a reason we have 4 spaces by default as our tab indentation, because after a while it gets too close to the end of the screen. Some of you might be familiar as well with the exponential indentation, which I really quite like. So, you know, keep indentation low. And for the polymorphism is when you've got a class that's has more than one behavior per the given input. And mutability is one of the more glaring facets of Kotlin, and it's made us much more aware of what's going on, because you might notice in IntelliJ, every var has its underline, which is a bit annoying. So it gives us this more context, it's more visibility about what's going on here. Here's another quote for you. There are only 2 hard things in computer science: cache invalidation and naming things. So a bit of a segue here. So meaningful names, naming is hard. This is one of my biggest pet peeves in API design, and that is poor naming. You have a really, really great opportunity when naming your parameters and naming your methods to take advantage of the full method signature going ahead for you. And it makes me sad to see that some people don't. So here, if you look at this example, you can see that we're using some single letter namings, which is, this example is obviously contrived, but what can we say that this snippet is doing? Well, we can see that it's doing an iteration and attempting a connection, but what is it operating on? What's the cause of the exception, and why is it being ignored? Well, if we simply just rename it to you know, client and index, we can see that we're actually iterating over a key set now with an index, and we are intentionally ignoring this exception. Maybe it's an exception thrown by an SDK that is purely for logging purposes, so we don't have to treat it with the same amount of importance. But it's these small little steps and small little changes you can make in your implementation that give it much more information about what's going on. And continue with the concept of using the entire signature to your advantage. Let's go through this kind of straightforward example of what you might see. Now, I wouldn't, of course, expect any sort of string manipulation function to be suspending, but you know, just take it as gospel here that this is a example. So, of course, we can see the internal. This is probably the strongest tool in our arsenal to ensure modular visibility. Is making sure that your code is only accessible to the same module, something that has been given to us in Kotlin. If you're trying to consume code that has been marked as internal, you're probably doing something wrong, or you're probably using Java. So not much to worry about here. But suspend, this gives us the information that the result will return asynchronously. It can only be accessed by a coroutine or another suspended function, but it gives me an idea that it might be doing something on I/O, it might be doing something network related, it's going to be doing something that's not going to return immediately. The infix notation from Kotlin, which is really quite nice when using receivers, but actually seeing that it's infix means that I know that it has to have a receiver and it has to take a single parameter. So that immediately gives me some information about what to expect in the rest of the method signature, a parity bit, if you will. Obviously, the receiver, which I mentioned, is going to be his string here, because obviously we're doing string manipulation functions. And it indicates the scope of the function. It must be called on a receiver of this extension type. So this is probably the most important part of your method, the actual name of the method. But let's not forget what we've already declared in the rest of the methods. We don't need to repeat ourselves. We don't need to say string contains other value will result in this, or does this contain it. It can be terse, it can be short, it can be descriptive, it can be accurate. Always use a verb when appropriate, and don't forget about using command query separation. Command query separation is the idea that a function should either be a command or query, not both. So either it modifies a state or it returns a resource. If you're modifying a state, make sure to use a verb. And this is obviously information about the parameter we're going to be providing. It's a string. And finally, we have useful information about how to use the results. If it were a live data or observable, we would know to then consume it by observing it. And this gives us information about how to use it. And it indicates that this is actually a query, not a command. So I forgot to put the animations on this slide, so you're seeing all the bullet points in one. Woohoo. So prefer interface composition over inheritance. I already mentioned this, but it's extremely important because inheritance forces the consumer to use a base class. And if your consumer is using more than one API, this is going to be a really big problem. So there's obviously not much room to kind of maneuver here. And then you have to use things like clever things like delegates, and it's a bit of a kind of shame. Obviously, there's limitations on extending abstract classes. You can only extend once, and that's an issue. And it can potentially expose protected behavior. So if you really want to fully abstract your behavior away from the interface, you'll have to use an interface because you need to move the implementation somewhere else. And you cannot yet use interface delegation with abstract classes. So that's a really good reason to use interfaces here. So a good example of this actually is what I found in the coroutines library using coroutine scope. Now you can see there's a simple interface here with coroutine scope that provides a coroutine context. And then there's an internal class, internal implementation for that, which provides that from the coroutine context. Now the API is really, really simple here, but you can see very clearly what it's doing, where it's moving the implementation to, and how your interface is really finely grained. So we have this public fun coroutine scope, and the nice thing about here as well is that the public fun is in the same file as the actual interface. So when using it from IntelliJ, it uses the same import declaration, so it recognizes the interface as though it were a constructor, which is super nice, and you don't have to use any of this companion objects invoke stuff, because that's actually really misleading in an API. And then, of course, using internal for the implementation, which is really nice. There's one of many examples in the coroutines and Kotlin API that I quite like myself. And one of the things you can do as well is to democratize your API decisions. This is something we did in Scout, but be aware that you don't want to do it too much, because you might end up becoming paralyzed a little bit by bureaucracy and by having too many stakeholders in the decision-making process. But you can do an impact analysis. You can contain your risks and kind of manage what you need to do. Peer review, always really peer review with your colleagues, and hopefully they will scrutinize your API, because these are the people that are going to have to be using it. Mob programming is always a great tool for working in large groups. I would recommend not using mob programming when you have a task at hand which has a known solution, such as something that has technical documentation for it already. Use mob programming when you want to work on APIs and you want to work on something that is not set in stone, that doesn't necessarily have a right or wrong answer, because it means everyone's on the same page and you can all work to the same goal. A bit over the top, but this is an Android API Council for the OSP, which is a really good demonstration about how the Google team actually manages their APIs. This is a group decision amongst people who then decide, do we want to move forward with this? Is this going to be useful to our consumers? And it's that second level of thinking that really kind of makes things concise. And finally, guild meetings, which is what we do in Scout, which is a bit more streamlined, and that is just we meet every fortnight and we discuss about things we want to change, new libraries we want to introduce. We discuss, and then we decide democratically within 20 minutes. It's actually quite a really nice tool that avoids the bureaucracy, avoids the slowness of this decision-making process. So with all this talking about API design, I would feel that I should probably mention the elephant in the room. Hope you all can appreciate the pun there. Modularization. Now, modularization is a key aspect in making your APIs concise and clean. It's a key aspect of any Android application architecture, and generally it's used for pretty much everything in Android, whether it comes from instant apps, dynamic features, modularizations, or anything like this. So it's really, really important, and there's a lot of people that would then think, modularize all the things because modularization is cool, it's a hot topic right now. Whilst they're not wrong, there are a lot of caveats that you have to consider as well. What are the main reasons for modularization? Well, it allows us to compile modules in parallel so that we can greatly improve our overall build time. And then it gives us the strengths. We can use cached or incremental compilations to make sure that we can benefit from these, and we can benefit from having a smaller build time from changing small sections of code which are highly modularized or in the right place. I'd be remiss if I didn't mention the build cache and scan available from Gradle Enterprise. You can also use the Docker container for Gradle to manage your build caches, which is really nice, and it can actually reduce the amount of bottlenecks you have. And if you're using Gradle Enterprise, you can scan your team's builds as well. This isn't a paid post, but if somebody wants to give me Gradle Enterprise, I'll be super okay with that. But the important thing to remember about modularization is that there are some pitfalls. It's not a silver bullet. You have to use it carefully because probably overall, if you're working in smaller modules, you are going to benefit from a faster build time. But for every module you introduce, there is going to be a small overhead. So your clean builds may actually be longer than if you were not using modularization. But that's just an argument for poor modularization rather than not having modularization. So you have to make sure you're carefully using it, make sure your product flavors are properly aligned, make sure your dependencies don't misbehave, and your configurations are configured correctly. You can usually find this out if you have a Gradle scan, and it's something to look out for. So I had this question during investigation from Pascal prior to doing this, and that if build time would be worse in a modularized app, would you still do it? And as mentioned, there are a lot of caveats to modularization which should be taken into consideration. But the answer is absolutely yes, I would. Even if the build time was actually kind of impacted negatively, I think modularization is actually a really powerful tool and allows us to use a lot of other things that can give us advantage. So incremental compilation for smaller modules. So with all this in mind, you might be kind of a bit apprehensive about building an API. So it's all kind of remember, we're all human. Mistakes happen. Don't beat yourself up about it. You can't really progress without potential risks, and that's sort of why we have the deprecated annotation. So there's always potential for risk. Make use of annotations. We have the deprecated, which has a really nice replace with migration tool. And there's the new required, well, not new, but requires opt-in, which was a renamed experimental annotation from Kotlin. This is where you can define your own annotations to apply to product features, and you can be really descriptive in how your API should actually behave. We've actually created a few of our own in Scouts. A few examples would be technical debt. This is about an improved to-do annotation because it means you have to actually reference a Jira ticket as well. And visible for modularization, which is something we used in the early days when migrating from Kotlin and things had to be public for Java. A really nice example of a migration tool here is when using the deprecated replace with, and you can then use the Alt and Option Enter tool in IntelliJ to replace all the usages of this in one fell swoop, which is really nice. And finally, with this topic, I think it's all too easy to fall into this problem with decision paralysis. If you're too afraid of settling on an API or not having a perfect API, then you're going to have no decision, or you're not making any progress forward. So remember that the word decision is a decision not made in time. Even a bad decision you can make, you can improve upon, and you can learn upon. So in conclusion, I think I would like to kind of summarize my feeling towards behavioral design or behavioral API design, and why it's important to abstract it and why it's important to kind of hide it away from your users. Because good code, is it code that documents itself? Perhaps. Code that can be changed easily? Is it easily and readily maintainable code? Follows all the design principles and makes Uncle Bob happy? No, I would argue that good code is code that could be easily deleted. The more easily you can delete your code, the more easily you can replace it. And I will leave this as a final quote. Every line of code is written without reason, maintained out of weakness, and deleted by chance. It's actually quite funny because as coders, we become much more unhappy about writing code than we were when we first started. So we're much more apprehensive, and that's the journey of the Android developer. Some further reading if you're interested. I'll post the links for these because they're obviously not short links, but it's explicit promote for library authoring. This is coming soon in Kotlin. 200 things. The annotated programmer, there's a great article from Chet who created a few parody annotations to demonstrate some of the frustrations he has in coding. One of my favorites is overridden, when you express that you as a programmer was overridden from the API decision that you wanted to make. And finally, an XKCD comic to throw it all in. Fine, and thank you very much. So, Q&A. Thank you all for attending. I'm going to do my best to answer your questions. I know we're a bit over time, so I'll be quick. What's your process for designing an API? Do you open a pull request and go from there, or do you do pair programming sessions? That really depends on the size of the API change and how much it's going to impact. So previously I said that you want to do a risk analysis and find out in how many people this is going to affect or how big this API change is going to be, and that really depends on how much time you're going to have to spend on it. So the more narrower or the smaller the API service you have, then it's a bit more room to play with, and you maybe can just go ahead and open a pull request. And depending on how engaged your colleagues are, they might notice that it's an API change. If you feel that it's going to have more of an impact, then we do paired programming. And if we actually have an architectural or application-wide impact, such as choosing a library like RxJava or coroutines, or choosing to go with a architecture paradigm, then we'll actually have a guild session where we will then sit down for an hour and discuss it. And then actually ahead of time, we'll also have a kata or a training exercise where we can all get a bit more familiar, so that we're all coming into the discussion with a bit of information about what's going on. So we're not just blindly saying, let's use this MVI library. So it's quite a useful tool. How do I dismiss this? Okay, never mind. Next one. How to avoid endless discussions about naming? Good question. How to avoid backshedding? Let me know when you find out. This is often a big problem, and I think I've had many hour-long discussions about how to name one method, but the important thing is to rely upon your colleagues, because these are the people that are going to be using it. So even if a name might make sense to you, you have to remember that the name isn't for you, it's for everybody else. So make sure that your colleagues and the people who are reviewing your code, make sure that they understand what the method is doing. And if somebody asks a question, hey, what is this method doing? Maybe that's a clue that it could be named better. And then you could then go pair with that person and say, well, what would you expect this method to do? And how could I improve upon it? It's much more constructive to work with your colleagues in a pairing kind of session, because everyone always thinks their own name is insightful and is more accurate. So I think it's really useful to just kind of sit down and have a pairing session and have a coffee. Do you have some best practices for variable and method naming? Beyond what I've gone through in this talk, I would say consider the entire method signature in your naming. So don't feel that you need to repeat yourself. So if it's in the method signature as a return type or a parameter, don't feel you need to put that in the method name as well. As I mentioned, use command and query separation, so that your method is either get resource or modify this or something, so that you can clearly tell there's a verb in the method name that says I'm going to be doing this, and then there's a verb in the method name saying I'm going to be getting this. And you can usually get away with only two-word namings. And a big red flag, I think, is if you find any control statements in the method name or variable name, things like and, or, if, things like this. For example, get and set if it's doing this, then you've got a lot of polymorphism going on there and a lot of kind of behavioral changes which are going to be hard to predict and difficult to maintain. So avoid control statements in your methods. Next, you mentioned build time as a pitfall with modularization. Do you have strong advice on dealing with this, best practices? Gradle scans. Gradle scans are your best friend here. You can then analyze, what's kind of the bottleneck in your build. You can see what's depending on other things. Most often than not, it's because Gradle has for some reason thought that it needs to recompile a module when it doesn't need to, or it's got a cache miss or something like this. So you can then, you can do a clean run and then do a follow-up run with the Gradle scan to find out, what changed and what you should be doing differently, or what, you can then chase down why this feature, this module was recompiled when it didn't need to be. And obviously, if you can, use a Gradle, use a build cache because they're amazing. Cool, next, would you use a core module and distribute shared dependencies by API, or prefer using implementation to speed up build time but duplicate code? Good question. I generally prefer to use implementation rather than API because it's a bit clearer to see what's actually being used in your library. And I think a lot of people actually kind of misuse it a little bit because they might use Dagger or something more something complex in their library or in their module, and then it needs to be there for some technical reason. API, I think, should only be used if your actual method signatures take or return something that is, that is actually relevant to that. So, for example, using RxJava, if your APIs actually return observable, then that makes sense to use API RxJava there. But I would actually be more inclined to duplicate code, but only once. Don't run it a third time. Running it a third time is obviously a point where you want to actually start reducing it. So yeah. We have lots of tools to implement to improve code, lints, etc., PRs. We spend a lot of time there. When to know how to see the limit between good and perfects? This is a really good question, actually. I think it's going to be subjective. It's always going to be subjective because one person's idea of perfect is going to be a little bit different from another person's. But I think you can probably make assumptions based on how much time you're spending on this. If you're spending excessive amounts of time chasing after this pipe dream, then it's probably, have a bit of realism, be a bit pragmatic, only spend so much of your time when it's necessary. But at the same time, you might just be really unlucky and have a legacy code base or something where there's a larger difference between what is good and what you have to work with. So we'll obviously have a lot of static analysis, as you mentioned, to analyze these things. And I think if you've got static analysis in place already, you can probably assume that it's reached a certain level of quality that you can then make your own decision from there. And if you're in a position where you're thinking, is this good or is this perfect? You probably already surpassed good, and you're shooting for perfect at this point. So, if it's, as long as it's not hurting our users, as long as it's not terrible code, and as long as it's kind of effectively modularized, you're probably okay. Final question. What about making a manifesto for naming architecture? For example, use fetch in the name to fetch from network, retrieve to retrieve for DB, etc. This is a really nice idea, and it works in some cases, but the downside to it is that everyone has their own idea for the manifesto, and everyone thinks that their idea is better than the other person's. So you really have to decide in your own team what is appropriate, what is good for use. So you want to sit down with your colleagues and saying, well, I want to move towards having the standardization of this naming. I think because we use this in X many places, or we use this type of technology, then it makes sense to do this. And then you can speak amongst your colleagues and say, yeah, we agree upon that. We're on the same page. And once you've got that agreement from everybody, then I think it's fair to actually put that into documentation for your team to say, 20 new hires, anybody who joins the teams, like, this is how we do it, this is what we do. And then it often comes into light when you're reviewing PRs and like, hey, this is the agreement we made. And it often comes up for us as well. So yeah, if you want to go ahead and in making a manifesto into this naming, I would definitely encourage it, but don't go over the top because it's very easy to spend a lot of time on this when it doesn't really bring you a lot of benefit. If you can knock out a definition reasonably quickly and without too much argument, then by all means go ahead. Awesome. So thank you everyone for attending, and I shall speak to you online.